In this video, we are going to look at how to determine oxidation number or oxidation state of an element in a chemical formula. What is oxidation number or oxidation state? Oxidation number or oxidation state refer to a hypothetical charge assigned artificially to an element when dividing up the electrons among the atoms in the molecule or ion. There are a few rules to follow to assign oxidation number or oxidation state for an element. Rule number 1, in a free element, so the element here refer to a substance which consists of one type of atom. And the element or the substance can either be atom or molecule. So in a free element, whether it is an atom or molecule, the oxidation number for the element is equal to 0. For example, sodium atom here consists of one type of atom, sodium atom. Bromine molecule here also consists of one type of atom, bromine atom. And magnesium atom here only consists of one type of atom, so it's element. Chlorine molecules here is also an element because only consists of one type of atom. And oxygen molecules here is also element because only consists of one type of atom. And the helium atom here, so they are all free element, therefore their oxidation number is equal to 0. Rule number 2, for monoatomic ion, the oxidation number is equal to the charge of the ion. For example here, sodium ion, aluminum ion, sulfur ion, chloride ion, magnesium ion, oxide ion, iron 3 plus ion, and manganese 4 plus ion. So these ions are all monoatomic ion, therefore their oxidation number is equal to the charge of the ion. Like for example, iron 3 plus ion with the oxidation number of positive 3 because the charge of the ion is 3 plus. One thing to take note is when we write oxidation number, we write the charge first, positive, for iron 3 plus ion, followed by the number. While for the charge, we write the number first, followed by the symbol of the charge. Rule number 3 is for oxygen. Oxygen has the oxidation number of -2 in most of the compound, except in peroxide, the oxidation number is -1. For example, the oxidation number of oxygen in magnesium oxide is -2, and oxidation number of oxygen in water is also -2. However, the oxidation number of oxygen in hydrogen peroxide, so hydrogen peroxide is peroxide, therefore the oxidation number of oxygen in hydrogen peroxide is equal to -1. Rule number 4 is on hydrogen. Hydrogen, the oxidation number is +1 when it is in the compound, except when it is combined with metal to form metal hydride. Then in metal hydride, the oxidation number for hydrogen will be equal to -1. So for example, the oxidation number for hydrogen in hydrogen chloride is equal to +1. However, when in magnesium hydride, then the oxidation number for hydrogen in magnesium hydride is equal to -1 because in magnesium hydride, the hydrogen combined with metal, magnesium, therefore it forms metal hydride where the hydrogen will have the oxidation state of -1. Rule number 5 is oxidation number of fluorine and other halogens. The oxidation number of fluorine and other halogens always is -1 in their compounds, except when they combine with oxygen, then the oxidation number will have a positive value. For example, the oxidation number of fluorine in sodium fluoride is -1, and oxidation number of chlorine in hydrogen chloride is -1, but when the halogen combined with oxygen, for example, the oxidation number of chlorine in dichloroheptoside will have a positive number of +7, and the oxidation number of chlorine in Cl2O is equal to +1. Rule number 6, in neutral molecule or compound, the sum of oxidation number of all the atoms that make up the molecule or compound is equal to 0. For example, in water, the oxidation number for water is 0, because the total of the oxidation number of hydrogen and oxygen in the water is equal to 0. Or we can just look at the charge. Water molecule has no charge, therefore its overall oxidation number is equal to 0. And so as potassium permanganate, the oxidation number of potassium permanganate is equal to 0 because the sum of the oxidation number of all the atoms in potassium permanganate is equal to 0. Or in other words, we can look at the charge of potassium permanganate. It is equal to 0. Therefore, the oxidation number for potassium permanganate is equal to 0. Rule number 7 is for polyatomic ions. For polyatomic ions, the total oxidation number of all the atoms that make up the polyatomic ions must equal to the net charge of the ion. For example, in permanganate ion, having the charge of -1, therefore the oxidation number for the permanganate ion is equal to -1 because the total oxidation number must equal to the net charge of the ion. And for dichromate ion here, we can see that the oxidation number is equal to -2 because the net charge of the ion is equal to -2. Now we move on to look at how to determine oxidation number of an element in a polyatomic ion. For example, here we have dichromate ion, the polyatomic ion. So for polyatomic ion, the oxidation number of the polyatomic ion is equal to the net charge on the polyatomic ion. Therefore, the total oxidation number of this polyatomic ion, dichromate ion, is equal to -2. And what are the elements that forming this ion? So 2 chromium atom plus 7 oxygen. And we know that for oxygen, the oxidation number is equal to -2. Therefore, by doing mathematical calculation, we can determine what is the oxidation number of chromium in the dichromate ion. So 2 chromium ion plus -2 multiplied by 7, -14, equals to -2. And therefore, this should give us +6 as the oxidation number for chromium in the dichromate ion. In example 2, we want to find the oxidation number of manganese in manganese 4 oxide and also permanganate ion. For manganese 4 oxide, we know that the compound is having total charge of 0. Therefore, the total oxidation number for manganese 4 oxide is equal to 0. And in manganese 4 oxide, it consists of 1 manganese atom and 2 oxygen atom. And we know that for oxygen atom, the oxidation number is -2. Therefore, for manganese in manganese 4 oxide, the oxidation number is equal to +4. And for permanganate ion, the total charge of the ion is equal to -1. Therefore, the oxidation number for the permanganate ion is equal to -1. And in permanganate ion, it consists of 1 manganese atom and 4 oxygen atom. For oxygen atom, the oxidation number is -2. So therefore, the oxidation number for manganese in permanganate ion is equal to +7. Example 3, we want to determine what is the oxidation number for sulfur in the sulfate ion. So sulfate ion is polyatomic ion with total charge equals to -2. So therefore, the oxidation number for sulfate ion is -2. And how do we determine the oxidation number for sulfur? So in sulfate ion, there is 1 sulfur atom and there are 4 oxygen atoms. And we know that the oxidation number for oxygen is -2, and therefore the oxidation number for sulfur in sulfate ion is equal to +6. Example 4, we want to find the oxidation number of chlorine in KClO3. From the KClO3 formula, we can see that the total charge is equals to 0, so means that the oxidation number for KClO3 is equals to 0, and in KClO3 it consists of 1 potassium atom, 1 Cl atom, and 3 oxygen atom. And for potassium, group 1 element, so oxidation number is positive 1. And for oxygen is negative 2. This should give us the oxidation number for chlorine in KClO3 as positive 5. Example 5. What is the oxidation number of uranium in UO2 2+ ion? Again, this is polyatomic ion, so the total charge is 2+. Therefore, the oxidation number for this polyatomic ion is positive 2, and it consists of 1 uranium atom and 2 oxygen atom. We know that oxygens with the oxidation number negative 2, and therefore the uranium in UO2 2+ ion having the oxidation number of positive 6. The last example, what is the oxidation number of carbon in C2O42- polyatomic ion? Again, the charge is 2-, so therefore the oxidation number for the polyatomic ion is equal to negative 2. And then it consists of 2 carbon, so 2 carbon and 4 oxygen. And we know that the oxidation number for oxygen is negative 2, and therefore the carbon in C2O42- ion has the oxidation number of positive 3.